All right, today we're going to do factor by grouping, okay? Now, one of the things they're going to rely on heavily today is what we did the other day with factoring out a greatest common factor. That's something that we're going to be looking for probably from here on out through factoring, but it's going to play a heavy part in factor by grouping, okay? Now, first things first, and we're going to start real easy, all right? Now, the first couple of examples that I've got up here, I have got these kind of preset up for you. All right, we're going to make a couple of observations. I'm going to give you a second to at least jot down that first one. So go ahead and jot that down. Okay, but like I said, I've got these kind of set up already, and that's kind of, I figure we'll try to start real easy. We'll kind of try to progress into it and see if we can get you mastering the art of factor by grouping. Okay. As you write that down, what is an observation that you make about the sets of parentheses?
Got to distribute.
Well, there is a distributive look going on. I like that. What do you notice about the parentheses?
There's a plus in between.
They have a plus. They are the same. They are the same. Okay? Now, factor by grouping. You must get two identical sets of parentheses. You must get two identical sets of parentheses. And like I said, I'm kind of starting you in a certain point with these right here with these first two examples, so I've kind of got you there, but that is a major observation you need to make is that when we do factor by grouping, both sets of parentheses must be identical. Okay? Now, what has already gone on here that I kind of did ahead of time for you is that I have already pulled a greatest common factor of 3x squared out of the first part of this problem, and I've also pulled a GCF of 1 out of the second part, okay? And that's precisely what you're seeing with that distributive type look. We talked about that the other day. We said, look, distribution, you're really distributing a GCF, okay? So I've already done that. We have two identical sets of parentheses, okay? So here's what we would do from this point. I want you to kind of look at this right here as one term and this as a second term, okay? In each of these terms, what do these two terms have in common? What is the same in both of those terms? What do both of those terms have in them that look the same? The parentheses, okay? So what we're going to do right here is we're going to look at these two things as two separate terms and say, look, both of these terms have a common 4x minus 3. And just like we do with pulling a GCF, we're going to look at this and say, hey, if 4x minus 3 is common in both of these bigger terms, I'm going to factor that out. I'm going to take that out of both terms. So I'm going to open another set of parentheses here. And I'm going to say, look, if I take 4x minus 3 out of this first term here, what's the only thing left? That's right. That GCF sitting out front there, 3x squared. So I'm going to put that right there. And if I take 4x minus 3 out of that second term, what's the only thing left? Plus 1. And now that one is done. I've kind of got this already set up for you. I've already taken the greatest common factor out. That's what you're seeing right here. Okay? The 3x squared and the 1 were GCFs that I'd already pulled out of an expression for you. Okay? What you have left are now two terms, basically, that have a common set of parentheses, 4x minus 3. So we're going to observe these two terms and say, it's almost like we're going to take another GCF. We're going to look at this and say, what is the same in both terms? What is common in both terms? And I have a common 4x minus 3. So we are now going to factor out the 4x minus 3. I'm going to pull it out front. And if I take 4x minus 3 out of both those terms, the only thing left is a 3x squared and a plus 1. And that's what's going in the second set of parentheses, which is going to complete the factoring of this polynomial. But this look, we need to be able to get to this look, and we will. But these first two examples, I at least wanted to kind of get you started right there and say, look, this is what we're going to eventually need to see. We need to see this setup with two identical sets of parentheses so that we can pull those identical sets of parentheses. So with factor by grouping, it's really almost like you're going to factor twice. You're going to pull two GCFs. Okay? If you take a look at the next one, do we have two identical sets of parentheses? We do, okay? And we need to see that. When we get to this point in the factoring process, that's what we need to see. That's one way you're going to be able to kind of check to see, am I on the right track? And if I've got that, we say, okay, let's proceed forward. What's common now, like I said, we're going to look at this as one term and this as one term. What's common in both those terms? The parentheses, 2x plus 5, right? So we're going to say, okay, hey, if 2x plus 5 is common, let's take that out. So I'm going to take that common set of parentheses, 2x plus 5, I'm going to put it out front, so to speak, okay? And if I take 2x plus 5 out of each of those terms, what's left? X squared plus 3. And that's what's going to go in that second set of parentheses. That is now, we have now finished that factoring process. Okay? But again, these two examples, I've kind of got you started already. I already did some factoring for you, got it kind of set up to where we can see those two identical sets of parentheses, and then we're just kind of finishing it up. Okay? I think the first couple problems on the assignment today will be just like that, kind of get you started, kind of get you into that look before we get into the full process. Okay? So far, so good? Okay. All right, so here we go. Jot that down. Let's look at the full process, okay? Now, as you're writing that down, I will say this. Generally speaking, one of the characteristics of a polynomial that will kind of maybe guide you towards doing this by grouping is the fact that you're going to see 4 terms. And that's what you're going to see with these, okay? We've got 3x cubed minus 4x squared plus 9x minus 12. We've got 4 terms there. 4 terms is usually a characteristic or something that tells us, hey, factor by grouping is probably something you may want to do here, okay? If we were to look for a greatest common factor at this point, guys, there isn't one. There is no GCF for all 4 of those terms. 3, 4, 9, and 12, I don't have a GCF for that other than 1, and 1 doesn't help me a whole lot. There is not an X in every term. So it's like, well, what do I do with a polynomial like this if I don't have a greatest common factor for all that junk? Well, here's what we're going to do. We're going to group it. So you're going to put a set of parentheses around the first 2 and around the second 2. And we're going to group this thing off and work on it in a couple of sections. Those first 2 terms, 3x cubed minus 4x squared, that's all we're looking at. What would be the GCF for 3 and 4? A 1, right? Okay, so let's put a 1 down. Is there an X in both terms? There is. Which one do we take? We always take the smallest one, right? X squared, exactly right. So the first 2 terms have a greatest common factor of technically 1x squared. Well, let's take that out. Let's factor that out. And remember, that's what we learned the other day. We said, look, when we factor something out, we're going to divide it out. Now again, division by 1 doesn't change anything. 3 divided by 1 is still 3. If your GCF for your big number's a 1, guys, the numbers aren't going to change. Now, what happens if I take 2 x's out of 3 x's? I got 1 x left. And again, if I take negative 4 and I divide it by 1, I've still got negative 4. That's not changing. And if I take 2x's out of 2x's, how many x's are left? None. Close parentheses. That's exactly what we did on Monday. A lot of binomials. We found a GCF. We've kind of got that look. Now, hopefully, if we do this right, guys, we should end up with another 3x minus 4 over here. That's something we're going to anticipate because we need two identical sets of parentheses here. 9 and 12. What would be a greatest common factor for 9 and 12? 3. So let's go plus 3. Is there an x in both? There's not. So we cannot pull an x in our GCF. So 3 is it. We're going to open a set of parentheses. If we take 9x and divide it by 3, what do we got left? 3x. Good. And if we take negative 12 and divide it by 3? Negative 4. There you go. Are we getting two identical sets of parentheses? Yeah. Yes. That means you are on the right track. Okay? If we're going to do factor by grouping, this is something we need to anticipate. And if we get it, we can say, look, let's keep going. Okay? Is everybody okay with where all that came from? Okay. Now, exactly what we did on the first slide, we're going to look at this as one term and that as one term. What's common in both those terms? 3x minus 4. And if you take 3x minus 4 out of both those terms, what's left? X squared plus 3. Factor by grouping. Yes, if you wanted to redistribute that, that's what you're doing, right? Yeah. If you redistribute those two binomials, we should get that original expression back. 3x times x squared would be 3x cubed. 3x times 3 would be 9x. Negative 4x squared. And negative 12. Now, it's a little different order, but we can rearrange that, right? There's my 3x cubed. There's my negative 4x squared. There's my 9x. There's my negative 12. And that's exactly what you would do. If you wanted to kind of check it yourself, it's just a redistribution. Guys, that's all this factoring business is. It's putting things back into that multiplicative look that's going to generate these expressions. Okay? And, by the way, I don't know if it'll be a question, but if you saw this answer written this way, that's okay. If the x squared plus 3 comes first and then the 3x minus 4 behind it, that's fine. Those sets of parentheses are interchangeable, so to speak. Okay? Because multiplication is commutative, right? 2 times 3 is the same thing as 3 times 2. Okay? So far, so good? Let's do another one. Okay? Again, recognition. Recognition that you're looking at 4 terms. 4 terms typically is a big tip-off that you're probably going to have to group. Okay? You're still looking for a greatest common factor. If you look at all that, I don't think you're going to find there's a greatest common factor better than 1 for all your big number stuff. That doesn't help a whole lot. And there's not an x in every term. So again, you look at this and you say, look, I can't take a GCF of this whole thing. So what do I do? Well, you break out a couple sets of parentheses. Group the first 2, group the last 2. What's going to be your GCF for the first 2 terms? X squared. I agree. You know, technically, big number stuff, it's a 1. But again, we already know 1 does not help us a whole lot. Okay? Now, if you take x squared out of both those terms, what's left? If we, say again? X and minus 1. If we take 2x's out of 3x's, we've got 1x left. If we take 2x's out of 2x's, guys, it wipes that term out. You have to show a 1 there. Saw that on a few worksheets the other day. I talked to a few people about it, but had some people turn it in. Still kind of saw that, so be careful about that. If your greatest common factor wipes out an entire term, put a 1 there. What's the GCF in the second set of parentheses?
2.
Positive 2. Is there an x common?
Mm-hmm.
Nope. Good. Open parentheses. X minus 1. Which we should already be anticipating. Guys, once you get your first set of parentheses, that's what we should be looking to get in the second one. Do we have 2 identical sets of parentheses? Yes. What's common in both these terms? X minus 1. And what's left over if we take them out? There you go. So you're you're seeing it now. Factor by grouping. And again, if you want to put the x squared plus 2 first and then put the x minus 1 behind it, it's fine. Get the same stuff. Okay? Good? All right, I think I got 2 more. Got 1 more of these, and then the last one, there's a little bit of a thing I want to show you kind of on the end just in case you run into it. But let's take a look at this. Got a little bit more going on here with the numbers. So a little bit more to look at. Again, it's 4 terms. 4 terms. There's not a GCF for all. What do? You're going to have to group. I said that's why, this is one of the reasons why that GCF stuff was so foundational the other day is we're going to have to be able to find the greatest common factor. There you go. Not over here much. Get a different perspective over here. Guys, what do you think about the first 2? GCF for 12x cubed plus 4x squared. 4. What else? How many x's are common? 2. Right? Always take the smaller. 12 and 4, it's going to be 4. X cubed, x squared, take the x squared. If we factor that out, what's left? 3x plus 1. I like it. 12 divided by 4 is 3. If I take 2 x's out of 3 x's, I'm left with 1x. There's your 3x. And then you've got a 4x squared taken out of 4x squared. Wipes it all out. You got a 1. Are you dying? Are you dying?
Yeah.
If you're dying, go. Because I'm almost done. Go. Go get her done, buddy. Guys, what do you think about the second set? 3x plus 1. What's common?
1.
Now, a little bit, you've got a 3 and a 1, so obviously it's got to be a 1, right? And there's not an x common in both. Now, for the grouping purpose, we need to go ahead and put the plus 1 there. We need to show a 1 up front. Guys, if 1 is the only thing we're factoring out and going to divide by, is that going to change anything? 3x divided by 1 is 3x. 1 divided by 1 is 1. We still have 3x plus 1. So with factor by grouping, if the only thing you can really factor out is a 1, go ahead and show that because we're gonna need to pull those sets of parentheses out, right? Do we have 2 identical sets? Yes. I'm assuming we agree that's common, so we're going to take out 3x plus 1. What's going to be left over?
4x squared plus 1.
Boom. There you go. Factor by grouping. Got 1 more. All right, any questions there? Everybody good with that? Okay. All right, last one. let's take a gander here. Rolled in another variable here. There's going to be another little part to this we're going to need to kind of talk about probably in the end, depending on kind of how we approach it. But just want you to be prepared. Four terms. There's no significant GCF up front, okay? X's, Y's aren't common. The big number I've got is a 1. Really wouldn't help me a whole lot. So let's go ahead and group this off. What do you think about the first two terms? What is the GCF of the first two? 1. And what else? X squared. There you go. So really, the only significant GCF in the first two terms is really just an x squared, okay? Again, hopefully we're starting to kind of discover a little bit that if our GCF is a big number 1, it doesn't help us a whole lot. Now, if I take x squared out of both those terms, what have I got left? Y minus 3. If all we do is take x squared out of x squared y, y is left. X squared coming out of negative 3x squared, we got a minus 3 left. So there it is, y minus 3. So now we've got a little bit of a preview as to what we need in the second set of parentheses. So now the second one, what's common? 3. Anything else? Is there a y in both terms? There's not. Okay, so 3 is it. Let's open parentheses here. Now, if you take negative 3 and divide it by positive 3, what do you get? Now, negative divided by positive, that's going to be negative y, 1y. And what's 9 divided by 3? Positive 3. Now, let's talk about this right here. Sometimes, and I had a couple people the other day ask me this on a couple problems. Sometimes you might look at one of these and say, how do I know if my GCF needs to be negative or positive? Because sometimes you look at it and go, should it be negative? Does it need to be positive? I don't know. This time, we pulled a positive 3. Here's what we got left. Are my parentheses identical? No. They are not. Okay? Now, that is something, again, that's why I've kind of emphasized that. We need to recognize that and go, whoa, hang on a minute. These are not identical. I cannot keep moving forward. Wouldn't it be nice? This is a positive y, this is a negative y. Negative 3, positive 3. Wouldn't it be nice if I could just change those signs? If I could just flip those signs, we would be good. So how we do that is we use the negative 1 trick. All I'm going to do is I'm going to take that positive right there and I'm going to make it negative. And then that would allow you to flip those signs. Negative 3 times y is negative 3y. Negative 3 times negative 3, there's my positive 9.
Can you do the same if it's minus instead of plus?
You could. If you get to a point to where all you need to do is switch some signs, that negative 1 trick will always work. Put a negative out front or change the sign of whatever's out front, okay? And by doing that, it's going to let you manipulate those signs in a legal mathematical way, okay? But sometimes you do kind of get in this quandary where you're going, well, do I pull that negative 3 out of there initially or do I make it positive 3? Well, if we make it positive 3, obviously we saw where the parentheses are not identical. And you kind of go, okay, wait a minute. Hey, look, all we need to do is switch the signs. Take that plus, make it a minus, change that sign. We still have the same expression. We've just manipulated the signs, but it's all legal. Okay? So a little bit of a special casey kind of thing in case you run into it, and that happens every now and then. Okay? Now, are my parentheses identical? Yes. So now we continue on. What's left over if I take out y minus 3?
X squared minus 3.
Boom. There it is. Now I'm done. Okay? But somebody may have looked at that and they said, you know what, I'm going to take -3 out of there. Okay, pull a -3. See what happens. If your parentheses end up identical, keep moving. If they're not identical, that's when you need to stop and say, okay, what do I need to do here? I may need to manipulate some signs, okay? Now I will say this, and this will not be a separate problem, okay? But that's factor by grouping. Okay? Questions? Question? 4 terms, typically not a GCF for all. Okay, still won't look for that, but let's group it off, get it factored, 2 identical sets of parentheses. I don't know, kind of feels like you guys already kind of got the hang of it, so sounds good. But let's say you had that. I think in a situation like that, it might be a little more apparent that you also have a negative that's common. So in something like that, I'd probably say, you know what, I'm going to pull a -4 because both items are negative, and I know 4 will go into both. I'm going to go ahead and pull, whoops, I'm ahead of myself here. That's going to be, what, positive x plus 3. There you go. So if both terms are negative, I think it's a little more apparent you want to pull the negative. But if one's positive, one's negative, sometimes you might pull a negative, sometimes you might pull a positive. But again, look for those identical sets of parentheses.